All right, so here's what you guys need to know about quadratic functions. You know a lot of stuff about quadratic functions already.
Yeah.
Okay, so what's a quadratic function look like?
A weird parabola.
Okay, good. So when you see the word quadratic function, I hope you're thinking parabola. That's good. What's a formula for a quadratic function?
X squared.
Y equals x.
How about what's the most general form for a quadratic formula?
X equals opposite b plus or minus this.
No, not that thing. We'll get to that thing in a second.
Okay, just as it
I
just
think-
squared
X
then.
squared plus x, or it's like a number x
X
plus
squared
number.
plus x plus b.
Okay, so there's some x squared,
Maybe
maybe a of them.
Yeah.
And then there's some x's, maybe b of them, plus c. So ax squared plus bx plus c. This is the first, well, part of the quadratic formula, right?
Yeah.
Okay, so should I write that off to the side so we don't keep screwing it up?
Yep.
Okay, so quadratic functions and the quadratic formula, although sounding similar, should live in different places in your heads. These are a tool that apply to those sometimes. Okay? So let me write down the quadratic formula. It's,
Negative b plus or minus square root.
oh no, where'd the first half go?
A squared plus b squared
No. That's a theory. How about
plus
if
c. Simple math.
ax squared plus bx plus c equals 0,
Oh.
then
Wow.
x is negative b plus or minus the square root of b squared minus 4ac all over 2a.
Yeah, I forgot that first part's kind of important.
Yeah, you need to know when this thing applies. So this thing applies if ax squared plus bx equals 0. You guys see that?
I hate that.
A quadratic function is a function, right? It's an f of x is ax squared plus bx plus c. So why do I have the quadratic formula near quadratic functions?
because you can substitute the 0, or assume it's a 0 output, and then you can solve it.
Good. If I'm looking for the x-intercepts of a quadratic function, I want to use the quadratic formula. You guys see that? For this thing to work, I need to assume the output is 0. You guys see that? Okay. This thing here is standard form. This is good for plugging things into the quadratic formula, right? There are other forms that are better for other things. So here's another one. Factored formula. So if we have a factored form, that's f of x is a times x minus r times x minus s. Okay? So why is that one maybe preferable in some ways?
If you don't have an x squared.
So one, I don't have an x squared, right? You guys see that? Which means that I can just read the x-intercepts off. The x-intercepts on this guy are an x, right? If I want the x-intercepts off of this thing, I got to run it through the quadratic formula. You guys see that? So drawing a picture of this thing might be easier because I know what the x-intercepts are already. You guys see that? Okay, what else? There's one more of these, and I promise it's awesome.
One more form.
Yeah, one more form. So there's also the vertex form.
Oh, this is the one I never could remember.
Okay, I think you probably have gotten to the point where you'll be able to remember this.
Yeah.
So this one is f of x is a times x minus h squared plus k.
Yeah, that's one.
Okay,
Yeah.
but now you know shifting rules, right?
Yeah.
That was the thing I was trying to
A few weeks ago, that was the thing I was trying to remember.
Yeah, so this is like a completed square. You guys all see that?
Yeah.
And so what they did was they took a thing in standard form, right? They complete the square on it, and they get this. And now I can think about this in terms of shifts, right? You guys see that? This is a right shift by h,
Stretch by
a vertical stretch, and a
shift
shift up by k. So if this thing's one of those U shapes, where's the vertex on this? It's up by k, so it's k high, and it's, where'd it go left, right?
H.
Yeah, it's right h. So the vertex for this guy is at h comma k. Okay, see that?
Okay, that's weird.
The vertex for this guy, I gotta like dig at a little bit. Do you guys remember a formula from Algebra 2 for that? Okay, so I'm gonna add this piece of information. This guy's vertex is at h comma k. This guy's vertex, right, the standard form vertex, is at negative, well, is over, x is negative b over 2a.
Oh, yeah.
What do I mean by is over?
Divided form.
Sorry, not the over 2a, but the vertex is over.
Oh.
So this one, right, a vertex is 2 points. It's an x and a y, yeah? On this one, I just have an x value, right? Where do I get the y that goes with that x value?
You plug it back into the formula.
Yeah, you got to plug it back in the formula. You guys see that? So the vertex on this guy is at negative b over 2a, comma, f of negative b over 2a. You guys see that?
Yes.
So if I have to draw a picture, I'm going to try to get things into vertex form because then I can look at it as shifts. You guys see that? If I just want to find the vertex and it's in standard form, I'm probably going to want to just remember that the vertex is over negative b over 2a. You guys cool with that?
What would you call the x equals negative b plus or minus? Is that a form or is it just a
Oh, this
form
thing?
of the standard form? Yeah. What would you? Is there a name for that?
Yeah, this thing is the quadratic formula.
Oh, okay.
Everything comes from that.
Yeah, quadratic formula is a if this, then that. It's a two-part statement. It's a theorem, right?
Mm-hmm.
It tells me how to solve these things.
Okay.
These guys are just different forms of the same function.
Gotcha.
And so some days they might hand me a function in vertex form, or they might hand me a function in factored form, or they might hand me a function in standard form.
Okay.
You guys see that? You get these things. Standard form things happen when you do physics. Factored form things happen when you know break-even values. So this happens when I'm like assuming something about profit usually.
Yeah.
And this guy happens when I made that parabola move around using shifting rules. You guys see that? So there's a situation for each of these, and they each kind of come up naturally in their own way. And I want you to know that they're all just different forms of the same idea.
So from Algebra 2, I remember something funky about the vertex form and using h. Do you take it literally as negative from in there, or do you change it to positive when the minus is still in there?
Yeah, it's got to be a negative in here. So you have to phrase it as, if I'm going, so for example, if I had if I had vertex form, right, so somebody gave me in vertex form, f of x is 7 times x plus 2 squared minus 8.
Minus negative 2. So that'd be negative 2.
Good, so this is x minus negative 2, right? And so my vertex went, left 2 units. You guys see that? But I knew it went left 2 units when I had x plus 2 in there, right?
Yeah.
So you guys know like shifting rules, right? So use that to your advantage. You don't have to make this match exactly the formula unless you want to use the fact that the vertex is at h comma k. If you want to think about it a little harder, go for it. Like that'll be easier. So, because that was a left shift by 2, I think it went left 2. And then, what happened vertically? Yeah, it went down 8, so the y value on the vertex is negative 8.
7x plus 2, then h has to be
You guys see that? So I would say that instead of maybe memorizing where the negative signs go in here and how this vertex comes out, I would just memorize that vertex form lets you use shifting rules. Cool? Because those are already taking up space in your head, so you may as well use them.
There's nothing else that lets you use shifting rules like the factored form.
How do you?
Yeah, so on the factored form, right, I don't have a consistent shift, right? You guys see that?
Shifted both up or down R and up or down S at the same time while stretching both of them.
Yeah, so the stretching by A I see for sure, right?
Yeah.
Like that's still a vertical stretch by A,
But then you're stretching by that.
but the right shift isn't consistent. You guys see that? So I don't know where this thing went. I can't apply shifting rule to this. I could multiply this crap out and then complete the square on it. That would
And
get
then
it into
get that.
this form. And then I could use the shifting rules that I know and love. But yeah, standard form and factored form aren't going to do shifting rules well for you. What they do well is pictures. So factored form does pictures super well. Right? Because I know it crosses at R and S. And it's stretched by a factor of A.
So just go up A between.
Yes,
the
that.
all pictures.
I don't know that it went through 1, but we could figure out where it went through. You guys see that? Where's the vertex on that one? Is that a thing that's also worth knowing?
It's between R and S.
Yeah, good. It's between R and S. Where between R and S?
Below.
Evenly between R and S.
It's what?
Like exactly between.
Yeah, it's exactly halfway between R and S. You guys remember that?
Mhm.
So these things are symmetrical and you can exploit that a little bit. Cool?
So half R and S.
No, 'cause that's the-
Yeah, if we were given R and S, we could straight up find it by averaging them or something. Cool? All right.